Hey guys, welcome back to joberTech channel. In our last video, we installed the Algolia extension for our Firebase project and integrated Algolia into our Flutter app. We used Algolia 1.1.2 as our client-side API to communicate to our Algolia backend. So here is the code we ended up with to fetch our users from Algolia backend. What we do here is to initialize Algolia class, passing in both application ID and API key inside our initState method. And when we tap on this search button, it triggers this fetch users function over here. What this function does is it clears out all previous results first to ensure that we are getting fresh results every time we search. We then create our query object using this syntax, passing in our Algolia index and the search query provided by the user. We then fetch the snapshot using this getObjects method, and then extracting the result by tapping on this hits field. And lastly, we add the results here in our results list and call the setState to rebuild the UI. Down here in our body, we display the results using the listView.builder. In each item, we extract the name of each users and display it within this list style. While this works, this is far from ideal for production because if you'll add all the necessary logic for production, you'll end up with a bloated widget that is hard to understand and reason about, like your monster wife when she is on her monthly period. So in today's video, we'll refactor this code to separate all the embedded logic, allowing our UI to focus only on data presentation. But before we write any code, we need to ask ourselves, how can we separate and structure our logic? Here at joberTech, we typically use this approach in terms of business logic organization. We have this controller class that handles the async state of the UI, this service class that handles business logic, and a repository class that communicates to remote data sources and serializes and deserializes data. So this is also how we'll structure our search feature. We'll have this search screen controller class, this search service class, and this user search repository class that will act as a wrapper to our Algolia client API. This structure is already robust enough when you only have one search feature in your app. But how about if you have more than one search feature? For example, you have a search feature for users and a search feature for products. This kind of structure would lead to code duplications because you need to define your API in both this user search repository and product search repository. And not to mention, you'll end up testing the same logic repeatedly. So what we're gonna do is to create a search engine class here and make it generic so that it can be reused by multiple repository classes. While our app currently only has a search feature for users, I'll be coding it this way to make it easier to add other search features when needed in the future without breaking our existing code. So that's the overall code structure we'll be aiming for our search feature. So let's start creating this search engine class. Let's inject Algolia class here to make it easy to swap out with Mac implementation for testing. So let's create our own version of Algolia methods. First, let's create an implementation of this index method that returns an Algolia index reference. Next, let's create an implementation of this query method that returns a type of Algolia query. But since this is anchored to this index method, let's make our index method private and pass it as a parameter here to our query method. Up next is this getObjects method. Since this method returns a future of type Algolia query snapshot, let's structure our own to return a future of type list t so that it can be configured to any type we need. Alright, what this method is doing is fetching this query using this getObjects method, then accessing this hits field of the snapshot, mapping its snapshot and passing its data to our builder function, then finally converting it back to a list. These filters and facet filters are a function used to add a filtering parameter to our query before calling this getObjects method. While we actually don't need this in our app, I included them just to demonstrate how to filter query when needed. So this returns an Algolia query that accepts the initial query, which is this one, and the filter parameter of type string. If you wanna learn how to write the filters, you can visit the docs by clicking on this. And voila! We can see various examples here. You can also see all the filtering methods that you need here. For example, this set numeric filters, set tag filters, and other more. We also have this set page and set hits per page, which are very useful for pagination. Okay, take note that this index name, search query, and search filter are all of type string. So to avoid misuse, let's define specific types for this. Okay, before we move on to our user search repository, let's create the Algolia provider and the provider of this search engine class. Let's run the build runner for us to be able to generate the providers using the code generator. Okay, what we did here is to initialize and instantiate the Algolia class in a provider. And then we create another provider of our search engine class. I also stored the application and API key in my environmental variable file and reading their value using the flutter.env package. By the way, if you're unfamiliar with these providers, I recommend checking out my video about Riverbed Provider, where I explain how to use it and why it's needed. But in a nutshell, these providers act as a reference to these classes, ensuring you access a singleton instance without a new instantiation each time you need them. Okay, let's now move on creating our user search repository class. Let's inject the search engine class here. Okay, the only thing we need to define here is our fetch users method. There you go. We are now using methods we defined from our search engine class. We define the query here, passing our Algolia index name and the search query, and then calling the getObjects passing this query. And here in the builder, we convert the data into an appUser object using this fromMap method, passing the data, and then return the result. As simple as that. If you need to use this filters method, for example, your users have a country field, and you only need to search users where the country is United States. You can simply define a filtered query here, passing this query object and the filter, like this, and then pass this filtered query in this getObjects method, just like that. Okay, let's move on to the user search service class. In our previous video, we already created this search service class, so we just need to add the future provider that we need here. Inside here is where you save the user's history to your database and define your fancy logic that you need before fetching the result. Okay, let's create the user search controller class. Okay, if you're unfamiliar with this is similar to a class that extends the state notifier subclass from the Riverpad package. The only difference is this was generated using code generator to save time rather than writing it by hand. The main responsibility of this is to manage the synchronous state of the UI. So it's similar to our state notifier subclass of type async value if you're familiar with that. Otherwise, you can learn it from these videos if you're interested in it. There you go. I think everything now is in place. Let's set up our UI and clean all the embedded logics inside. Okay, let's do a quick summary on how this system works before we test. When this search button is clicked, it will call this method inside our controller class. Inside here, the state of our controller is then set to async loading. And inside our widget, it checks if the controller is loading. If so, this circular progress indicator is displayed. While the UI is loading, this method inside our search service class is called. What this does is to update this search query provider to the search query provided by the user. After this is now where the magic happens. Because once this provider is updated, this future provider who is currently watching this search query provider gets initialized. This triggers this function that is responsible for fetching the users from our Algolia backend and converts it into a list of app users. And back to our future provider, this now holds and caches the fetch list of app users. So the next question is, how can the list of app users displayed in the UI? Well, if you're familiar with Riverpad, You already know how this works. But for those who are new to Riverpad, let's display this to our UI. The first thing we need to do is to watch our future provider inside our build method. And here in the body, we tap on the value of our provider and use the when method. This method encapsulates three functions that we need to provide: the data, error, and loading. For our error, let's just simply return a center text, and then let's return a circular progress indicator in our loading function. And then here in the data, let's return this list view.builder. Since our data outputs a list of app user, let's do a bit of modification here. Okay, everything now is in place. We can now test this. There you go. Flawless victory. That's it, guys. Today, we journeyed from a basic, tightly coupled implementation of Algolia search feature to a refined, structured, and more maintainable version. We dissected our code, understanding each part, and then rebuilt it using best practices. By abstracting our logic, we've paved the way for easier testing, future expansion, and clearer code readability. We also delve into the power of providers and how they streamline our app's logic and state management. Remember, good code isn't just about getting things to work. It's about crafting solutions that stands the test of time and growth. Thank you so much for tuning in, guys. If you found this video helpful, please give it a big thumbs up, share it with your fellow Flutter enthusiasts, and don't forget to hit the subscribe button because this would encourage me to create more valuable content like this.